Everybody, welcome to Data Engineers Lunch, number 18. Today, our speaker is going to be Obi Amnachi, who will be speaking about Luigi for scheduling processes in the data world. I'm your organizer, looking for co-organizers. Organizers get to get new people in. You don't really have to be able to talk on a topic, but that would be nice if, if we need somebody to step in sometimes. Data Community DC is the larger group of meetups that we're a part of with people from different backgrounds. Data Wranglers DC is just one of many groups, and there's a little bit of everything for you out there related to visualization, data science, full stack data science, you name it. What do we cover here? We cover the perennial and ubiquitous problem of moving data, processing data, cleaning information so that people can actually use it for business reasons. That may be to create dashboards, to explore information, to find insights beyond just looking at something and seeing if something is going in the right direction. And then obviously machine learning is a big, and data science is a big part of it. Data engineering covers a bit of the software engineering, but also has some knowledge of what the data scientists need to do, as well as some knowledge of what are the data analysts going to need. We have a few new people. If you'd like, you can just unmute yourself, unmute your video and say hi. Normally in the real version, physical version of this meetup, we would have people go and say hi to somebody they didn't know. So if you're new, well, you're welcome to take, quick second to tell us who you are and maybe what you can speak about or what you're here to learn. Anyone, any volunteers? I don't know if you can unmute yourself or not.
Hello?
Hey, yeah, go ahead, Stephen.
Hi, yeah, this is my first time.
Okay, welcome, Stephen.
So I'm mostly a web developer. Like I build websites, and I'm slowly starting to get into the data science realm, as they call it. And I'm trying to learn as much as I can. So thank you for having this.
Great, welcome. Yeah, there's a lot of skills in the web development world that you can leverage in data engineering. I think to make slightly bigger impact. That's just my personal opinion. Anyone else want to say hi? All right, cool. Okay, well, group rules. We are a community. We want you to take part in the presentation. Just be polite. If you want to add something to what somebody's saying, you can either put it in the chat or politely just mention it. Ask a question if you have it. Depends on the speaker. They may give you slightly different guidelines, but we want this to be a conversation rather than just a one-way presentation. Our company, Anant, we help professionals build very, very large-scale global data platforms, mainly around Kafka, Spark, and Cassandra. And so data engineering is our world. DataStax is a partner and a sponsor of this group. So is George Washington University, who has given us venue space and hopefully will after everybody's vaccinated. So if you aren't vaccinated, go get vaccinated if that's your choice. Data Wranglers DC has a few local sponsors, Chicago and DC, looking for other people to mention here. Our organizational sponsors, they fund the whole Data Community DC nonprofit foundation, which puts on events throughout the year. We have a Data Week DC coming up in October, first week of October, and they're looking for volunteers and sponsors. Anybody have announcements that are relevant to this group related to data?
I had one announcement and I posted the link in the chat, but if you've missed past data engineer lunches, you can go to that repo in the chat and all the information related to them can be found there.
Great, Josh. Thank you. Awesome. I know there's a few other topics coming up. here at Data Engineers Lunch, as well as Cassandra Lunch, which happens on Wednesdays. There's always events at Data Community DC. Let's take a look and see what's happening. Will, anything from your end? Any new things happening that I should mention?
Yep, absolutely. I was about to say 2 quick announcements for upcoming meetup events. Tomorrow on Tuesday the 6th, there is the Data Ops DC monthly meetup, and they're going to be having some of the data engineers from Snorkel AI talk about how they do data ops in their ML platform. That should be really interesting. And then on the 8th, Thursday of this week, we're having the DataViz DC monthly meetup event, and that should also be a lot of fun, more on the front end of once the data is, ETL'd, aggregated, and analyzed, how do we communicate that? That should be a good event.
Great. Awesome. Thank you. Any other events? Anybody looking for work or hiring? You can also just put it out there. All right. Well, without further ado, I'm going to hand it over to our presenter, Obi.
All right. Thank you. Give me a second to get everything set up. There we go. You should be able to see my screen. Today's Data Engineers Lunch, we're going to be talking about using Luigi for scheduling. This is sort of part of an ongoing kind of a series that we've been having for the last couple of Data Engineers Lunches that I've been on. I've been talking about Airflow and Jenkins as scheduling tools, workflow scheduling tools, and today we're going to talk about Luigi in that same vein. So Luigi is by Spotify, which I think Airflow also was. And it's a Python package that helps you build pipelines of batch jobs. So it's meant specifically for batch jobs, not like real-time stuff. And its specialty, how they describe what it's meant for, is for if you have long-running or a large number of batch jobs. It was built specifically to work with Hadoop and HDFS, but it's essentially meant to organize all of your long-running data tasks. So it has a different sort of niche than Airflow and how we sort of talked about Jenkins last time as well. But we will get into that now. Okay, so the base unit of work in Luigi is a task. By the way, I think it actually is named after the Mario brother because how they describe it is that it handles the plumbing of your data engineering workflows. But it breaks up work into tasks, and tasks are Python classes, which is, I think, slightly weird that we're doing object-oriented Python with this tool. But they're Python classes built with these Luigi-defined classes and methods. So your class definition takes one of a number of Luigi task types. So a base task type or a Spark submit task type that ends up creating a, Spark job to run your code. Parameters get defined with the Luigi.parameter class or any of a number of similar classes. Requires method is a method called requires that defines dependencies on other tasks, which you can sort of see down at the bottom what we're talking about here. In input method defines a number of input types, so you can say local file or S3 bucket, or there are various Hadoop defined ones, and they define where the data comes from that is used to execute the task. An output method is sort of the same. You can have it output to various databases, Postgres, MySQL. I did not see one for Cassandra, but there might still be one. And then lastly, the run method defines the actual behavior that your task executes when run. You run it via command line, and that's where you put any of your processing. and we can use the sort of images at the bottom to see input and output definitions, task dependencies, sort of. That's actually something that's missing here. One of the methods is specifically for dependencies. So in the same way that in Airflow, you would define a sort of dependencies list at the bottom when you were defining your tasks. Here, each individual task class has its own dependencies section where you list all the dependencies for that, and it can build you a sort of graph in the same way that Airflow did. But you see, you can define the output of one task as the input of another task, and then use requires to define that dependency. Here is an example task. You import Luigi, and you create a class that takes a Luigi.task as an argument. And then you have your individual methods inside, parameter definitions, requires, run, output, potentially also input. And since you have your dependencies defined in code, you can dynamically define them. So different types of dependencies that Luigi will be able to handle includes doing sort of date algebra. So in this case, you have this is a top 10 artist list. Like I said, it was built for Spotify for a particular date interval. In this case, it's a month interval. So it's doing the algebra there and creating tasks for all of the dates in that month. And the top list task depends on all of them. You can use that same sort of logic to do a sort of recursive definition of a task, as long as you're defining it in the same way you do in code with actual like recursive programs to avoid infinite loops. You can have a condition that creates tasks recursively until the certain condition is met. And then you can also have your tasks depend on types from particular other tasks. All right, so Luigi has something that they call the central scheduler, which is a singular central server for running tasks. It ensures that only a single instance of a task is running at any given time, and it provides a visualization layer and some like tracking and log tracking. What it does not do is trigger execution of tasks. You have to do that from the command line, except as dependencies. You can, of course, when you trigger a task, all the dependencies will be run. It does not time schedule anything. So in comparison to Airflow and Jenkins, which had that option, Luigi does not actually. And it does not distribute workloads or parallelize jobs. So when the central scheduler creates a worker to execute a task, that worker will essentially do all the steps in order based on the graph of tasks that are built for it. So this is what the central scheduler sort of looks like. You can see this is an example running the aggregate top artists for a month. So you have 31 individual, they're called streams jobs, but essentially what they're doing is gathering the data for each day in that month. And then you have the aggregate tasks, which depends on all of those. And then you can also get a sort of readout of whether you have pending tasks, failed tasks. Yeah. And one of the things that Luigi is lacking, again, in comparison to Airflow and Jenkins, is that sort of internal like retry mechanism. So both Airflow and Jenkins had a number of ways to define how many tries to take, what to do in case of failure, and all that sort of stuff. And while Luigi has ways, it has I think it's Hubot, possibly Hubot, but you can use that to create a sort of alert system to tell you when jobs have failed, but it does not necessarily do anything when jobs fail. So if you wanted to actually do scheduling like you would in Airflow or potentially Jenkins with how we talked about it last time, which is time scheduling specifically to run jobs on a particular time on a particular day, you would need to combine Luigi with cron or some other scheduling tool. You could potentially use Airflow or Jenkins to run these same sort of Luigi data pipelines. You can use the requires method in order to stop runs when data is missing, combined with cron to retry over and over again in order to have a Luigi task that triggers when data is loaded. And you can also just use cron with your Luigi tasks as written in order to have them run on a schedule. And it's this same sort of cron definition as we talked about briefly last time. We have minute, hour, day of month, day of the week. And you can define those to be either relative or specific. So you can say every 30 minutes, or you can say on the 30th minute of the hour. But I do not believe that there's any like specific interaction with the sort of labels that we had access to in Airflow and Jenkins at daily, weekly, monthly, that sort of thing. And of course, even with Luigi and cron, you're still lacking some of that functionality that Airflow had. So you would potentially combine it with some sort of cron monitoring tool in order to get some of that functionality back. So comparisons with versus Airflow. Luigi has a minimal API where Airflow has a number of different APIs for every level of interaction. If you wanted to run a DAG in Airflow, or if you wanted to run inside of that DAG a particular task, you could do that with Airflow APIs, where you don't really have that access with Luigi. Airflow is a distributed and scalable, at least Airflow 2.0 scheduler, where Luigi is not. And in fact, Luigi workers essentially have a single thread. They run tasks in order, except for special ones like the Spark submit that will send execution to be done elsewhere. So you'd send it off to a Spark cluster and Spark would distribute the work. Obviously, Airflow includes calendar scheduling, which Luigi doesn't, but they both use Python and they both use a sort of directed acyclic graph structure to define when, well, in what order various jobs get run. Versus Jenkins, Jenkins defines pipelines, but we talked last time, pipelines have to be linear. But you can trigger them to build off each other. So if you wanted to build your own complex directed graphs of individual Jenkins tasks, you could do that. But Luigi just has the ability to build graphs of tasks. Jenkins also has calendar scheduling. Well, once again, Luigi does not. Jenkins includes a number of other build triggers. So you could do CI/CD or trigger on various other things like repository updates, whereas Luigi does not have any build triggers at all. And I mentioned a little bit how you could potentially replicate that sort of thing by having jobs that do nothing when the data is missing run on a schedule, so that when the data is there, they run as soon as possible after that. And then internally, Jenkins uses Jenkins files, which define work based on command line commands. And then you could use it to run scripts, whereas Luigi defines its work in Python classes. But like when we were talking about Airflow, you can sort of get access back to the command line and different OS tools using Python's OS and sys modules. So we're going to be moving on to a demo in a bit. If there are any questions, you can speak up or put them in chat now. We're just going to go over a little bit of some of their inbuilt examples. look through the code, look through what happens when you run it.
Is that just the main Luigi repo that you're pulling
Yeah.
down on GitHub?
Yes, so I'm using GitHub to open this mostly because it has access to their examples.
Sweet.
But you don't actually, to run Luigi, you don't need this repo.
You can just install it using like pip or something?
Yes.
Ah, sweet.
When would one use Luigi versus another framework? Well, so like I was just saying, Luigi is easy to install, but any choice beyond that will be based on what you need to do. So we talked about time scheduling and monitoring being something that Luigi's not so great at, even when combined with cron, which might lead you to choose Airflow or Jenkins or some other tool. But like they say, Luigi is sort of built for managing the plumbing between your long-running data processing jobs. So if you have oh, I missed install. Yeah, so I wouldn't say that there's one that's specifically better and one that's specifically worse, but depending on what you're using it for, um, sometimes Luigi is enough and sometimes Luigi is not enough. So first we can see about running Luigi. This is their basic aggregate artist. Sounds like Luigi is simpler than Airflow. Wouldn't you recommend using Luigi over Airflow? So yeah, I'd kind of agree with that. I think have Luigi having these defined input, output, task types and run method make it a little bit easier to use than Airflow system of defining DAGs. And let's see, when would I recommend using Luigi over Airflow? So I see Luigi as sort of more of um, a pipeline definition tool. So I'd compare it more to if you use Spark MLlib, it has a sort of ML pipeline class that's used to combine some number of machine learning and data processing tasks into a single class that you can run and it'll do all the steps in order. So I think Luigi is sort of more like that, but with the ability to define a DAG, whereas Airflow is sort of a scheduling and management tool. So Luigi is sort of for putting all your ducks in a row and executing them, whereas Airflow is a process for sort of managing any other sorts of more complex processes. So you can see in this example right here, we're actually using this tag local scheduler, which runs it independent of the central scheduler. So you'll see that we have definitions of various tasks being done. And then when they all finish up, we get messages relying on that as well. but we have not actually run the central scheduler at the moment. So, and also we used local scheduler. So even if we had the central scheduler opening, we wouldn't be able to see anything. So if we now run the central scheduler, don't know why it always fails the first time, but I guess it just takes a little while to start up. So you can see you have your task list with all the various different types of tasks here. When tasks run, they'll show up here, including all of the dependencies. All of the tasks that are run as dependencies to whatever tasks you're running will show up here with various data about them. You can look at your dependency graph for a task. You can look at what the workers are doing, but like I said, they're not all that interesting since they run your work in sequence. So if we were to get a new terminal, if we were to run this again, but without local scheduler and with a different date interval, because all of the files that this task would create already exist. Now, if we go here, you can see we have a bunch of streams tasks for different dates, parameters, date, a particular day. And then we've also got a single aggregate artist task. One of the things that you can do, which I haven't really talked about, is that you can set priority for your tasks so that tasks with the same dependencies have an order in which to run. Otherwise, Luigi sort of just picks arbitrarily. But if you want certain ones to be run before others, you can do that with the priority. We can go look at the graph for this, show upstream dependencies. Why is that not? I pick one of these. There we go. So we can get the full graph here with all of the streams jobs, and then the aggregate artist jobs that depend on them. You can hide your dependencies or hide tasks that are done. And you can also look at their code visualization type if you want.
Does it, maybe I had stepped away for a little bit. Does Luigi have a set of basic runners? So like if you did not want it, you did not want to do a Python process, if you just wanted to run like a shell script or something. I mean, I know you can do that in Python, but does it have any basic ecosystem of tasks already built into it?
Well, there are different types of tasks, but I don't know if any of them are specifically for that. Like, where's the Spark example? Here, they're using, is that the one I was looking for?
I mean,
No, this is the actual Spark.
Yeah, that's that. I think it's there.
There's a version of aggregate artists that uses Spark, and it's specifically based on luigi.contrib.spark
Oh,
Spark
okay.
submit task. So it's a particular type of tasks made for Spark submit.
Mhm.
But I haven't looked through all of them, so I don't know if there's specifically one for doing like shell scripts or whatever.
Yeah, it looks really clean and concise.
Yeah, that's definitely one of the advantages. Like we looked at the internal code for Airflow, and it was a little bit less human readable, I would say. Um,
Yeah.
yeah, but that's all I have for today. There's more time for questions or other discussion now.
Thanks, Avi. Great, great tool. Good discovery. This is the first time you played with it?
Yeah.
Nice. Good stuff. Yeah, it's interesting how you were kind of comparing it with Airflow and Jenkins. And I actually ran into a tool called Chronitor over the weekend. But basically, here, I'll share my screen. The reason I found it was because like you keep running into cron, how do you write cron examples? And I came into this utility, which, is this it? Yeah, here it is. So anyways, the company that publishes this site it's Chronitor, but like there's a bunch of examples that you can just be like, I want this every 7 days or whatever. And then as you type it out, so like I want to do something all the time. Like everybody wants it run every minute, right? And you can say, every second minute or every 50th minute, every second hour or something like that. But the company that makes it is this Chronitor.io, which you install on your hosts, and it wraps your cron jobs, and then it monitors them. You discover it, and it kind of like wraps it with its own. I guess probably it's like a shell file that wraps it, and it then does the execution for you the way you want it to do it. But then it goes all of a sudden into your Connector IO desktop or dashboard. So when you were showing Luigi, I was like, this is very similar to, I could probably use Luigi for what this Chronitor is doing, basically, which is making it easy to see how everything is run in a consistent way. And does Luigi need any database?
I don't think so.
Cool. Yeah, that's the other thing. When I didn't hear that, I was like, this is much easier, because with Airflow and Jenkins, maybe in Jenkins you don't need a database. I think they all use database.
Well, no, I
but
think Jenkins does.
Yeah. Well, good stuff. Anybody have any other questions or thoughts on Luigi or scheduling data processes in general?
This was great. Thank you.
Awesome. Anybody have any other questions about data engineering that you want to bring up to the group to chat? We talk about stuff. We still have 15, 20 minutes. Yeah, JB, you had a question? No, okay.
I have a question totally related to another thing with respect to the Cassandra and Spark. It is like a noisy neighbor. Anything you can enlighten on the noisy neighbor? How
So noisy neighbor being the problem where, in general, in platforms, it's the concept that there's one quote unquote tenant of a multi-tenant system that is doing more things, correct?
First thing is, I want to know in my system there is a noisy neighbors.
You want to find out if there's noisy neighbor. Okay.
Yeah. Then, okay, who is that noisy neighbor is?
I see. Okay. Gotcha. So you're talking about from a pure database perspective, how to do it.
Yes. From
Okay.
the, I have one full set of the operations, everything is running. I don't know whether that issue is there or not. Now,
Gotcha.
first thing I have to find out, okay, everything is normal or something of this kind of stuff is there. Then, okay, then you can find out how to isolate or reduce that issue.
Yeah, I think this is probably a question for Cassandra.Link, but from a basic database perspective, it can be a kind of a data engineering question, which is you have a lot of processes running, and at least in some of the stuff that we work on, there's a platform that we design and build and help operate, but then the organization starts to put more and more workloads on it. So that workload is it's a multi-tenant in the sense that there's different divisions of a company that are using the same data and analytics platforms.
So in this particular case also, for example, since I'm trying to use the scheduler, right? And I'm trying to schedule all the jobs from one machine.
Yeah.
That will also become an issue, right?
Right. That's right. Yeah. If you're doing too many operations from like one machine versus kind of spreading it out, you mean?
Yeah.
Yeah. I would say that could be noisy neighbor, but I would look at that probably more as like data or traffic skew from a
That what
particular
I
place.
felt it is an application issue, because as a part of an application, I'm just trying to issue that, but because I know it.
Yeah.
As an application owner, I know it, what I'm doing, and thereby it is not a issue because of the neighbor.
Gotcha. So
It is an
the
application
question,
issue.
yeah. So the question I have is, do you think that the noise is coming from? See you later, Will. Do you think the noise is coming from different tenants, or do you think it's coming from different applications, or do you think it's coming from different servers? Because those are three different types of problems.
Yeah, that's what it starts with, like that. Okay, I have multiple applications, and noise can, when I say noisy neighbor, it can be from the different application itself, or it can be a noise from within the application itself. What I mean to say is, if my data is queued, okay, and it goes, all the requests goes to one particular node, then also it can be a noisy. That node will become noisy.
Gotcha.
Other way is application with respect to application, in the sense I'm asking the same data hundred millions of times.
Yeah.
That means again I'm going to that particular node for many times. For that time again, has to be handled by the application.
Gotcha.
Again, whether the question is those kind of things will be categorized as noisy neighbor or not, I'm not sure.
Gotcha. Yeah, I mean, it's a generic problem. If you come down to it, it's do we separate the work on many computers? Do we separate the work properly on many computers, such that all the machines are doing equal work? Right. That's the challenge of a distributed data platform. And when you have a noisy neighbor or whatever, process, server, tenant, right? It doesn't matter. It impacts the stability of the whole platform, the whole service. And so it's a relevant challenge for data engineering. Let's say you have ETL processes running, and one ETL process creates a lot more problems than others. How do you find that, right? And so there's this aspect of instrumentation that every system should have, whether it's a transactional system or if it's an analytical system. It doesn't really matter. I think it comes with experience when you realize, like, you can't just randomly put crap apps up. Right? You have to have a set of basic logging in place that is getting aggregated, number one. You have to have potentially some specific metrics that you are looking at in your processes that you are measuring, either by sending it to a time series database, or you're logging it, and then you're letting the log aggregation and analytic tooling help you there. But if you don't have good logging of errors or timeouts, like, forget taking an inventory of what are the processes and putting a start timer, stop timer, and logging how long it takes. Forget even that. Let's just say your application is timing out. The ETL process is timing out. The API is timing out, right? When do we see that happening? On which machines is that happening? So if you have a good logging system in place at every layer of the application, not just the the database, but your ETL application, your API itself, maybe even on the user interface to be able to see how long certain things take. If you have logging, then you can put all that into a log analytics tool like Splunk or Elk or whatever people have. And you can do basic search-based correlation and causation analysis. But if you don't have that information, it's extremely hard. It's like, like I'm on the board of a housing association, right? It's a condo building, and the electricity company says, your bill is going to be $1 million this month, right? I mean, how am I going to go find that unless I had meters set up on every unit to tell us who used what, right? And I don't even do that. Like the utility company does that. So if you think about it like that, maintaining a platform is kind of like maintaining a utility. To be able to really charge for the utility, you need to measure what's happening. And so some of the measurements could be purely ingress related, some of the measurement could be egress related, and some of it could be storage related, right? And you have to put in the tooling if it doesn't already exist. I think databases have some instrumentation, like if you turn on audit logging, things like that. But if you're using the same user, right, then you have to go deeper and say, when I'm inserting data, am I putting this customer ID, right? Versus if you're using different user per particular tenant. So it's a complicated answer, but I think it's a fairly simple strategy, which is log everything, what's happening, and you do that because you can, after the fact, see who did what and why did this happen because when they did that, right? You can see, like, for example, if it's like Cassandra has a system.log. Spark has a master log and a worker log. You may have a Luigi process that's doing stuff. It may have its own log. You may have an API that has its own log, but it's important to see all the layers of the system sending these messages, because if you don't have that information, I think it's extremely hard. And that's just my approach to it. I don't know if anybody else has had a problem where you have to figure out like what's the problem child of the whatever platform you're working on. Any thoughts, guys? I know there's more people who hear that have worked on these things. Yeah. Well, it doesn't seem like anybody's speaking up today. Hey, Mike, how are you doing? Yeah, that's good.
Hello. Hey.
Hey, did you have any? I just saw you I saw you hop on. I don't know if you were earlier, but like, did you have any announcements for our group that you wanted to talk about? Any events coming up?
Yeah, sure. Well, I have my event that's coming up. I posted in the chat here. It's on April 22nd. Best practices of contributing to statistical community forums, and it's going to be a pretty good. I'll post that here, and there's also some other announcements. DC2 is looking for volunteers. If you're interested in volunteering, feel free to send me an email. Let me go ahead and find that here for you.
This is for Data Week DC or Data Community DC in general?
Oh, this is just Data Community DC in general. We're looking for volunteers to help us manage our website and also marketing, and also to help support meetup organizers like myself and others.
Awesome. Thank you.
Yeah, thank you.
Very cool. Cool. Well, folks, there's no other further discussion. We can call it a day, and we'll see you next week, same time, same place. Have a wonderful week, folks. Enjoy.
Thank you.
Yeah.
Bye.